Today I'm going to talk about the homework tutorial books from page 31 to page 35. For the first questions, a string is tied to a book and pushed lightly as shown at the right. The book remains in contact with the book and does not move. So for the first one, draw a free body diagram for the book and label each of the force exerted on the book as you were instructed in the tutorial force. For the first one, generally, there will have the weight of the book, which is go straight down, and the weight of the book will equal to the mass of the book and times gravity. And at the opposite direction of the weight of the book, there will have a normal force of the book, which is from the table. Because the string is pushed slightly at right, so the tension neck for directions is go right, so go to right, so the tension is directly go to straight right. And for this, there will have a friction force, which is from the table, is go to the opposite direction, which is left. So for B, compared to the force exerted on the book when the string is not present, so the force are the same is the weight of the book, which is the max times the gravity. And also for seconds, there is the normal force will be the same. The force that change is the pushing force, which is go to the right, and in here it is the tension force, and also the friction force, which is the kinetic friction, and also the kinetic friction force, which is from the string. For second, consider the following statements made by students about a book at rest on a level table. The two forces exerted on the book are normal force and direct up, and the weight of the book directed down. Those are equals and opposite to one another. By Newton's third law, they are a third law force pair, so the normal force is always equal to the weight of the book. The statement made by the student is true for the book at rest on the table, as there is no string and no hand pushing. The book adding to the book, the force adding to the book are normal reaction force and the weight of the book. By Newton's third law, these forces are equals and opposite. For B, consider a box on the top and a level tables while the book is being pushing straight down by a by a hand. So there will exist the weight of the book, which is the mass of the book times the gravity. And also there is a normal force of the book, which is from the table, is on the opposite side of the weight of the book. And also there is a hand pressed the book straight down, so there is a force which is the pushing force. So for this situation, I can find out the normal force is equal to the weight of the book plus the force which is pushing. Compared to the force exerted on the book when the hand is not pushing. So in this one, the force keep the same is the weight of the book and only the weight of the book. So the force change is from the first one, the force pushing is from the 0 to the constants. And second, the normal force will change from the normal force is equal to the weight of the book to the normal force is equal to the max of the weight of the book plus the force which is pushing. So the magnitude of the weight is not equal to the magnitude of the normal force exerted by the table on the book, because in this one the weight of the book is equal to the normal force minus the force which is pushing. So the weight of the book is smaller, is less than the magnitude of the normal force exerted by the table on the book. Review the answer to part A. In addition, read the portion of your physics text that discussing Newton's law. Consider a book on a level table. So when the book is at a rest on the table and there is no any pushing by hands or it does not move, the normal force exerted on the book will the normal force exerted on the book and the weight of the book will be the third law force pair. And if it is rest. So if there is a hand push, straight down the book, the normal force will equal to the weight of the books and the force which is pushing. So for second one, the normal force exerted on the books by the table and the weight of the book will be the third law force pair when it is at rest. So when hands push the book straight down the book, so the weight of the book and the normal force minus the force of the pushing will be the third law force pair.